SwayamPrabha. Digital India. Educated India.
Shall we start now? So, the slurry reactor, I think till here I have also written in between those steps, step 1, step 2, step 3, step 4, and what is left now is writing an equation for each and every step here, and step 1 and step 2, step 3 is mixing, mixing of A in the bulk. So, that will not contribute, so that is why we have not written. Step 4, oh that is all, step 5, yeah, step 4 and step 5, right. So, these are the 4 steps which we have to take into account, and as I told you, step 1, step 2, step 4, step 3 also are all mass transfer steps, right, and again you have to use only that simple convective mass transfer equation, right. Okay. So, that is why this I am writing now for step 1, step 2, step 3 all equal to. So, minus R A B bulk will be, we have yeah, kg Ag, I will let you know what is Ag, Cab Cagb minus Cagi. That is why this diagram will be very good for you, because you can identify what is the concentration gradients, right. So, this is the first concentration gradient in the film. What film is this? Gas film. Then you have the liquid film. Through liquid film, we will write here as KL, yeah, Ag. Now, what are the concentrations now for this one? Yeah, Cali. So, that means concentration of A in liquid, right, but this earlier one is gas. You cannot write here liquid, because the gas concentration is the way you calculate is different, liquid concentration is different, that is why you have to be careful there. So, that is why here Cali minus what is the Cal, that is the concentration gradient here. Now, through the film which is around the particle, around the catalyst particle, we have yeah. So, this we call it as generally Kc, this also we call Ac, then we have Cal minus Cas. Okay. This again this concentration gradient. That is why this imagination is very important in all heterogeneous systems. Okay. Why that imagination? That will give me clear picture of what are the equations I have to write. And to get this level of imagining and then writing the diagrams, these pictures, you need lot of information in your mind for the process. All these things are only in the mind, and then that mind you translate this one and afterwards this one on the paper. Then it is very easy for you to write mathematics, right. So, that is why we started that. Now, what is the next step? Next step is rate of reaction, but this rate of reaction step again imagination, it is not imagination, we have to find out separately without all this, whether it is first order, second order, or some orders, right, or it need not be first order, second order, it can be even any crazy type of equation, right. But for simplicity, we will now take this one as simply K reaction, or simply we will write K only, AC Ca, yes, that is where the reaction is taking place, okay, on the surface. Good. So, if it is porous particle, then you have another gradient here which is inside. So, this gradient will be a function of R. That means, if I take the particle and then look at the concentration how it is changing, right. So, the A is diffusing through the pores and definitely it offers resistance, and then you have the concentration gradient. You know how you can beautifully you can take care of that by what is called affinity factor. So, this is the rate of reaction, this multiplied by eta, eta is the affinity factor which you would have heard of, right, because most of you have taken 2 courses. So, catalytic reactions, there is what is called an effectiveness factor, where the rate, the actual rate divided by the rate at bulk conditions, at bulk conditions. If it is isothermal reaction, then always inside the particle you will have less concentration and outside you have more concentration, okay, isothermal, right. So, that is why the rate of reaction based on bulk will be more than rate of reaction based on the concentration profile that is inside the particle. So, that is why you get effectiveness factor less than 1. This all these details again we have to discuss in the course chemical and catalytic reaction engineering. Okay, good. So, that is why that also can be taken by simply multiplying by eta. Eta is a wonderful concept in chemical reaction engineering, that also we can discuss in the next course. But right now we are assuming non porous particle. So, that means there is no internal diffusion and all that coming. So, simply it is this constant multiplied by CAS. Okay. Now, this is the equation. So, if I take this one as 1, this will be equation 2. Yeah. So, here I need a relationship at this point, that means CAG is coming to the interface. Now, it is dissolving. After dissolving, it shows CALi. That is why at interface we have written CAGI and also CALi. So, how you connect this one? Henry's law. So, that is why we write here CAGI equal to H into CALi. This also that equation also you require 3. So, now using this equation, that means now what is the procedure approach? We have the universal approach in heterogeneous systems. So, that is why I am telling now in all my course in heterogeneous system is very simple for many people, because the approach is very clear. It is only mathematics which are more complicated depending on what kind of reactions you take. Okay. What is the approach here? We started this one with the catalytic reaction, we started with the non catalytic, we now starting writing that one for slurry reactor. What is the approach now? Yeah. So, now I have to express this rate in terms of measurable quantities, that is called observed rate, global rate, even bulk rate, measured rate, all these things. Okay. So, this is also one of the questions I gave out of that 30 questions. Now, if you remember, you would not remember now anything, okay, but I know you are all excellent deleters, and I told you, most of you, all of you have PhD in forgetting how to forget, okay, not how to remember, very quickly you forget. But anyway, so now you first take these two, eliminate CAS, then these two eliminate CAL, then these two eliminate CAL, CAL and CAG using this equation, and finally you express in terms of CAG bulk. That is how, that I will leave it to you, I may give in the examination. Okay. Unless you practice that at least in your room, it is not that easy for you to solve this in the examination hall. Okay. You will take a lot of time, right. So, that is why you try on your own, and the final expression I will give you as minus RAB equal to, you see this is the kind of equation what you get, CAGB bulk. So, then I have here AC by AG 1 by kg plus AC by AG only, right? Okay, AG, then H by KL plus I have H into 1 by Kc plus 1 by K. So, this is the equation, where still I have not mentioned what is AC and what is AG and AC. Okay, AC and AG are the surface area, this is the AG is interfacial area per unit volume of bubble slurry, bubble free slurry. AG is interfacial area Okay, interfacial area means it is gas liquid, right? Interfacial area of gas liquid per unit volume of bubble free slurry. Yeah, okay, bubble free slurry. And AC is surface area of catalyst, yeah, per unit bubble free, per unit volume of bubble free slurry. Yeah, bubble free slurry. Why we have to do that is, I will give you a clue. This is equation number 4. Now, can you tell me what should be the units of minus RAB? If you take simply kg into CAB minus CAS, general expression I am telling, okay, kg into CAB minus CAC, I think that is a concentration. What are the units? Just tell me. That means I am talking about minus RA, yeah, simply kg into CAB minus CAS. Master.